In this lesson, we're going to learn about periodic behavior and be able to identify what it is. By the end, we'll be able to recognize periodic motion from graphs, we'll be able to graph a periodic function based on the description of its motion, and we'll be able to determine these three things from a periodic function: its amplitude, axis of the curve, and its period. There are so many examples of periodic behavior in real life. For instance, the setting of the sun, a heartbeat monitor, wind turbines, a Ferris wheel, and even a rotating electric fan in your own home. These are all examples of periodic behavior. We're going to use the high roller as an example, and this is the largest Ferris wheel in the world. It's located in Las Vegas. So we're going to use the information below to sketch and model the height of the high roller. The highest point of the high roller reaches 550 feet off of the ground. So if this is where the highest point of the high roller is, then from that highest point to the ground, that is 550 feet. The diameter of the wheel is 520 feet. So from one end to the other end of the circle, that is 520 feet. So that would mean that from the other end of the circle to the ground, this distance right here at the bottom, this is 30 feet. Because 520 feet plus this 30 feet make up this full height of 550 feet. And we also know that one revolution on the high roller takes 30 minutes. So what that means is when you get onto the high roller, you're starting at the bottom here because that's when you go in. And one revolution, so that means one full revolution around this whole reel will take 30 minutes to make your way back to the beginning where you started. So we're going to use all that information to sketch our graph of the height of the high roller, but let's organize the information in our table of values. So at the beginning of this ride, the time is at 0 minutes, but our height is not at 0 minutes because at the bottom of this Ferris wheel, at the bottom of this wheel, we're right here. We're not at 0 feet from the ground, we're actually at 30 feet from the ground. So this part might be a couple levels or steps above the ground. So at the bottom, we're at 30 feet. And this graph is going to model one full revolution. And one revolution takes 30 minutes. So at the end of one revolution, at 30 minutes, we're going to be back at 30 feet. So this is after where we have already made our way around the high roller. Halfway through this 30 minutes, we are at the highest point. So half of 30 minutes is 15 minutes. So right here, we're going to put 15 minutes. And at that point, at the highest point, we are at 550 feet. So the height is 550 feet. And then we can fill out the rest of these quarter points. So this is 1/4 right here of a rotation. If it takes us a full 15 minutes to get to our highest point, then half of 15 minutes will just reach a quarter. So half of 15 minutes is 7.5 minutes. So we can put 7.5 in at a quarter. But what's the height here? Well, right here at a quarter, we're just half of our diameter, so it's our radius. But half of our diameter, half of 520, is not where the height is, because we need to include this 30 feet off the ground. So it's going to be our radius plus 30 feet. And our radius is just 260 meters, or 260 feet. So from here to here, this is 260 feet, plus an extra 30 feet, that's 290 feet. So at 7.5 minutes, we're at 290 feet. So a quarter away from this point, we're at 15 minutes, and that's at the maximum height at 550 feet. So we already have that point on our table of values. But if we move another quarter away, this is going to be just another half of 15 minutes. So from 15 minutes, if we add 7.5 minutes, we're going to be at 22.5 minutes. And our height here is the exact same height we had at 7.5 minutes. So our height is 290 feet. And then another quarter away, we're back at the beginning. So this is a full 30 minutes, and then we're back at a height of 30 feet. So that was one rotation of the high roller, and let's graph it. Time goes on the x-axis. So I went up by intervals of 2.5 minutes. Every box is 2.5 minutes. And the height is always going to go on the y-axis. So here, every 3 boxes is going to be 100 feet. Our first point is 0 minutes and 30 feet. So it's approximately right here. At 7.5 minutes, we're at 290. So 290 could be approximately here. At 15 minutes, we're at 550. And that's just over here. At 22.5 minutes, we're right here. And at 30 minutes, we are back at 30 feet, just right here. So we sketched out all of our points, but we're not going to connect these with straight lines because looking at our wheel, the height is not increasing at the same rate that time is moving. So when we start, the height is increasing slowly, but right around here, it starts increasing much faster, and then it starts to slow down again. So there's going to be a curve here when we connect our points. So it's going to look somewhat like this. So this is just one revolution of our wheel. It represents the height in respect to time. And what happens if we were to go around again? We would get the exact same curve. So this is that periodic motion and that periodic behavior. Our graph would just repeat over the same interval. So let's learn some of these terms. A function is periodic if it has a pattern of y values that are repeated as the x values change. And that also means that the graph is going to repeat itself at regular intervals. So just like our previous graph on the high roller. And there are 3 things that you need to be able to identify on a graph of a periodic function. That's the period, the amplitude, and the equation of the axis of the curve. One complete pattern is called a cycle. So on this graph, this could be a cycle. And then another cycle, it could start at any point. It could be considered right here. This is a cycle. So it doesn't matter where the cycle begins, but the end of the cycle, you should end at the same y value where the cycle had started. And the horizontal length of one cycle is called the period of the function. So for example, looking at this graph, where I started the cycle right here, highlighted in yellow, this is one cycle. And the period of this function, the horizontal length of one cycle, is 4 units. Here's another periodic function, and this time we're going to look at the amplitude and the axis of the curve. So the amplitude of the function is half the difference between the maximum value of the function and the minimum value of the function. And on our graph, it's labeled right here by A. And to understand what the amplitude is, it's helpful to know what the axis of the curve is. So the axis of the curve is the horizontal line that cuts our periodic curve in half. It cuts our periodic function in half. So on our graph, our axis of this curve would be this blue line. And let's just compare the amplitude and the axis of the curve. So we know that the amplitude is half the distance from the maximum to the minimum values. But the amplitude is also the distance from our maximum point to our axis of the curve. And that's the same distance from our minimum to our axis of the curve. To calculate the amplitude, we're going to need the maximum point and the minimum point. So our maximum point here is 5, and our minimum point is -5. So to find the amplitude, we're going to do 5 minus -5 and divide that by 2. So our amplitude is just going to be 10 divided by 2, which is just 5. And our axis of our curve is that horizontal line that cuts our periodic function in half. So it's right in the middle of the maximum value and our minimum value. And an easy way to remember how you find that is, how do you find the middle of any two numbers? Well, it's like finding your average. So what you need to do here is you need to take your maximum value and your minimum value, add them together, and then divide them by 2. So in this case, we're taking 5 plus -5 and dividing that by 2. And we're just going to get 0 divided by 2. So our equation is just y equals to 0. And remember, this is a line, so we need to write the equation of this line. So our axis of the curve is y equals 0. And now I want you to go back to our graph of the high roller and on your own determine the period, amplitude, and the equation of the axis of the curve, and then come back to the video to check your answer. So the period was 1 full revolution of the high roller, which took 30 minutes. The amplitude is actually the same thing as our radius. It's just half of our diameter, which is 260 feet. And the equation of the axis of the curve, it's 290 feet. In this next periodic function, we're going to determine the period, the maximum, the minimum, and the amplitude. So let's first start off by drawing one cycle. And we can start it right here, and it's just going to end right here because our cycle starts back up again. The length of the cycle is the period. So in this case, our period is 2 units. This would be our maximum value. So our maximum is 1. And then our minimum value, our minimum y value, is just over here. So our minimum value is 0. The last thing we need is our amplitude. So you can find the amplitude by just looking at this graph, because our maximum is at 1, our minimum is at 0. Halfway in between 1 and 0 is 0.5. So the distance from 0.5 to 1, our maximum, is just 0.5. But you can also find it by using our formula. So to find the amplitude, we're going to take the maximum minus the minimum, 1 minus 0, and then divide that by 2. So 1 divided by 2 is just equal to 0.5. So our amplitude is equal to 0.5. You're going to do this next example on your own. So you're going to sketch the graph of a periodic function that has this period and amplitude, a period of 6 and an amplitude of 4. So go ahead and create your own, but I'm going to do one as well. So we need a period of 6, and it can go from 0 to 6. And then we need an amplitude of 4. So that means the distance from our maximum value to our middle, our axis of our curve, needs to be 4. So if I want my maximum to be at 6, our middle would be at 2, and our minimum would be at -2. So I can start my graph at 0, and then go down to my minimum value, then up to my maximum value, and at 6 I need to end back at 0. And that's one example. Here's our last question. So a periodic function has a period of 12. And then it gives us some other information. So f at 7 is equal to -2, f at 11 is equal to 9, and then we need to determine the value of f at 43. So we haven't really done a question like this yet, and we don't have enough information to sketch the graph of this function, so let's actually use this information just to make a table of values. So let's make a t-table. So on the left, we're going to have our x values, and on the right, we're going to have our y values. We've only been given 2 points on this graph. So f at 7 is equal to -2. That point is 7 and -2. And when f at 11 is equal to 9, that point is 11 and 9. So let's put that information into our table. Our first point, the x value is 7 and our y value is -2. And then the second point that we have, the x value is 11 and our y value is 9. Now how can we use our period? The period is the horizontal length of one cycle. So if I were to just draw a random periodic function, just like that, this is one cycle. So the period of this cycle would be 12. So whatever our y value is at the beginning of this cycle, so suppose it's -2, at the end of that cycle, our y value is also -2. And the only thing that changes is the x value, because we just added 12. So what we could do is if we add 12 to our first point, if we add 12 to 7, we're going to get 19. And then the y value is going to be -2 again. And if we add 12 to 11, we're going to get 23. And then our y value is going to be 9. And we can keep doing this until hopefully we get an x value of 43. So if we add 12 to 19, this time we're going to get 31. And our y value is going to be -2 again. And if we add 12 to 23, we're going to get 35. And our y value is going to be 9. And then if we add another 12 to 31, our x value is 43, and our y value is -2. And this is what we want. This is what we were looking for. We were looking for the y value when x is 43. So that means f at 43 is equal to -2.